So in this video, I'll be talking about closed air systems. So in this Word document I set up, I already prepared the diagrams for the initial conditions and the final conditions. The initial conditions is the container with 1 kilogram of water filled is open to the air, and the pressure, the atmospheric pressure of the air is equal to 1 bar, which I converted to PSI, and then I converted to pascals, which is about 100,042.93. And it's not heated at this point in time, and the temperature is 298 Kelvin. And then the final conditions, the pressure is at 2 bar, which is equal to about 200,085.86 pascals. We have the vapor, the volume of the moles of water, which is 0.3 moles of water in the vapor phase. Get that. And then it's the container sealed, and then it's heated. So some of the water is going to turn into the vapor phase, which is 0.3 moles. And we're trying to find the volume of the entire container and the final temperature. So first thing we do is the air and water have pressures. And air is made up of nitrogen, oxygen, argon. So we need partial pressures. So P of air will be equal to P of nitrogen plus P of oxygen plus P of argon But to make this simpler, we're just going to assume that P air, we don't need to solve the partial pressures of nitrogen, oxygen, and argon. So in total, P total is equal to P equal to P air plus P water. And we also need to know is no heat is added to the container. Until it's sealed. If it wasn't sealed, this problem would be extremely difficult to solve, if not impossible. And then we need the vapor. So another important concept is the vapor and liquid water are in equilibrium at boiling point in water. What this really means is the temperature at the surface of the water is the same as the temperature as the vapor in water. So first thing we need to do is find V of the vapor. So V vap equals to V total plus V water initial. So the V's mean volume. So to find V vap, we have V total, not plus, minus initial. After you complete that step, so there's another equation that we need. So ideal gas law. So, which is PV equal to nRT. So, which need the moles of air. So manipulating this in air, initial will be equal to P air initial plus V, or not plus, multiply by V that. So you get that, and then you divide it all by R times the initial temperature, so Ti, to get the amount of moles of air. And once you get the amount of moles of air, you can also find the total pressure. You can also find the final temperature of the system once you get to VVAP also, because you need the vapor pressure of water, and this depends on the temperature of the water, and that's what the water vapor pressure curve is for, so we can get a certain vapor pressure at a certain temperature. So the vapor pressure of water, so it says we need 0.3 moles.
Yep.
So to find the final temperature, it would be TF is equal to, let's see, you get TF is equal to times T, the vapor pressure, so VP water times V VAP. Put this in parentheses, divided by R, which is a constant, 8.314, if we're doing pascals and meters cubed, and then that times the N, or the VW, which we have earlier, which is the amount of moles of water. So that solves one variable. And to get V container, let's go down. Get the V container, you could do P air. So P air times V air. So I'm just going to write the general equation equals N air times R, let's see, times T initial. And you can rearrange that to get V air equals N air times R times T initial divided by P air. And V total equals V air plus V W volume of water. And this should be the same as V total minus V water. Or no, VVAP plus VWater. And that is all I have about the first concept of a closed system there and how to get the unknowns by using multiple equations and relating them.